Hi friends, this is Ajaz Kadri. This is the first video in the Simulink tutorials. Today we are going to see what is a Simulink and why Simulink. Today I am not going to explain how we can use Simulink, but I will explain what is Simulink and why we are learning. So let's begin. Simulink is a graphical programming environment for modeling, simulating and analyzing the multi-domain dynamic system. Now it is looking complicated, but at the end of this video you will be able to understand what this means. Basically, Simulink is a mathematical modeling and simulation software. So first thing may comes in your mind is what is a simulation. So we'll start with that. These two images will give you some idea about what is the simulation. It is an imitation of the real system. In simulation, virtually we are creating the same system as the real system. The simulation is carried out to study the system's response or its performance under various conditions. These two images is showing simulation example. The first one is the very good example of simulation. This is the racing car games. Most of you have played that. That is nothing but full complete simulation of real driving system. And the second one, in the second image is there is a simulation for tracking the projectile of missile. Nowadays, simulation is a very useful tool because at the initial stage of product development or design, we can check the performance through the simulation and we can make changes in the parameter. The simulation is used in many fields like in defense research, automobiles, aerospace research, and also for entertainment in games and movies. In movies nowadays they are using CGI techniques. That is also simulation. Many times people are getting confused between the simulation and analysis. Simulation we have already I explained. So now we will see analysis. Analysis is the study of effect of various parameter on the component of the system. Analysis can be carried out on the real system or on the physical prototype or in CAE software also. Analysis is used in the design of every component or system. For mechanical engineers, when we heard this analysis word, first picture comes in our mind is colorful stress distribution plots of CAE software. That is a stress analysis. But now question may come in your mind, can we call this stress analysis a simulation? And the answer is yes, we can, because we are creating the CAD model same as the real component, and then we are applying the force same as how it is applied in the real system. So in short, we are doing imitation of the real system, so we can call it a simulation. But every analysis is not a simulation. Suppose you are doing some failure study on some metal component. So that analysis you are doing on a real component, real system. That is an analysis, but not a simulation. I think now the difference is clear. If still you have any confusion, please put comments. Now we will move forward. Why Simulink? Why we need to learn Simulink? I will explain this with a simple example. In this spring mass damper system, we are applying initial displacement x and we want to find the oscillations of the mass. So for checking these oscillations, we are not going to build the real system, but we will do mathematical modeling. we will write the equations and we will solve it. We can also call it a simulation because we are replacing the real system with a group of equations. So this is also simulation. So in mathematical modeling, first step is to write the governing equation for components. Here we have three components: mass, spring, and damper. First, the governing equation for mass. For mass, force is proportional to the second differential of displacement, that is acceleration. So here the force due to the mass is m into mass into acceleration. This force is in the same direction of the displacement. Now the next thing, damper. So damping force is proportional to the velocity, but the damping forces are always in opposite direction to the displacement. So that is this negative sign. The next thing is the spring force. The spring force is proportional to the displacement, that is also in opposite direction of uh, displacement. Now we will consider the equilibrium condition and we will combine all these equations. So finally we will get this second order differential equation. So for calculating these oscillations of mass or displacement with time, we need to solve this equation multiple times. That is time consuming and tedious. So we have to do, so what we have to do is we have to write a code or a program to solve this equation. We can use any programming language like a C, C Sharp, or any other programming language, but here I am going to use MATLAB. Here in MATLAB, first I have created this function named equation. This is nothing but our equation, and here I am adding the parameter values, coefficient of damping, spring stiffness, and mass. The next I have created this script. Here I am solving this equation with the help of this ODE45 function. In MATLAB, we are readily getting this solver. If we are using any other programming language like a C++, then first you need to define this solver. First you need to write the program for that solver. After that I am creating plot. So after writing this program, what we need to do is just need to run the program. And here we got this oscillation or displacement of the mass with the time. This spring mass system is a very simple example. This is a very simple example, but for complicated system, it is really difficult to write the governing equation and also to solve the differential equation, and then the third part, coding. For most of engineering branches other than CS and IT, especially for mechanical, the coding is the alien language. We never knows the coding. We don't like it. So what we can do? How we can solve such a complicated problems? And the solution is Simulink. Uh, in the beginning of the video, I have told that Simulink is a graphical programming environment, and now I will explain how that is. In Simulink, we have provided a ready-made library of various components. You can see hydraulic, magnetic, mechanical, in mechanical translation elements. So here what we need to do is we need to just drag a component from this library and drop in our model and then connect it with the other components. Then add the parameter values. Now your model is ready. But in background of this component, we can see the program or code, source code that is written by Simulink. But for us, there is no need to write this program. Just what we need to do is just drag and drop the components. So that's why it is graphical programming language. Programs are there, but we need to deal is with only with this graphics, this building blocks. So after creating this model, what we need to do is to select the solver and then press the run button. Okay, so now your results are ready. Now we can see here. This is also the same as what we got from our programming. We can compare both. Yeah, both are same. You can see it. So in Simulink, there is no need to write equation, no need to write code or solve them. And best thing is ready-made libraries are available with so many domains, and we can connect that components and we can connect various domains. So that's why we are learning and we are using Simulink. That's it from today's video, guys. Thank you for watching, and don't forget to like, share and subscribe, and if you have any confusion, please put the comments. Thank you. And in next video we will learn how to use the Simulink.